In the late 1800s, there was a device known as a Crookes tube, which looks like this tube here, which was being passed around to the universities of the day, and people trying to understand it. It consisted of a battery attached to a vacuum tube, which is simply a tube to which they put a small hole in it, heated it until it was orange hot, and then sealed it up, thus forming a relatively permanent and very powerful vacuum. They managed to get a couple of wires in there sealed airtight as well, and they simply attached the battery to this tube. And what they found was that it emitted a green light. However, this light was unlike any light people had seen before. If you put a magnet near it, the light was deflected, which normal light does not do. If you put a propeller within this device, which took some doing, but they managed to do, and it was particularly hard to control the temperature. It has to be done isothermally, but if you do that, the light can push the propeller, which light cannot push anything. So that's also interesting. Nobody could understand it until J.J. Thomson took a look at it. He was a battery expert, and he'd been studying putting different gases in these things. So he knew certain values for hydrogen, neon, you name it. And what he was particularly interested in measuring was the mass to charge ratio. He could measure the charge of the battery, he could measure the mass inside the tube, and he'd get a number, mass to charge ratio for all the elements. They gave him this thing, which had pretty much nothing in it, and he found that it was whatever was in there was 1,000 times smaller than a hydrogen atom. Hydrogen was pretty well understood at that point to be the smallest possible atom, so he had to make a radical proposal. What he proposed was known as the corpuscle. It became known as the electron, and it's to this day understood to be what is in there. That is essentially an electron beam. These vacuum tubes became the progenitors for things such as television sets. They're largely replaced now by transistors. But for Thomson, he had to come up with a model, and he suggested that the atom consists of some sort of a sphere. Within it there are little electrons, and what they're doing and where they're located he had very little idea. This was known as the plum pudding model, and that is our symbol for J.J. Thomson. This is Thomson's 1897 cathode ray tube experiment and the discovery of the electron.